I mean, if we imagine that all the cars were connected and automated, I think there are solutions out there and robust solutions. But when we put the human in the loop, then we create a source of uncertainty, and this will make things more complicated. We're here in the Information and Decision Science Lab. In the IDS Lab, we develop data-driven system approaches for cyber-physical systems that they have a cyber component and a physical entity. And we try to make these cyber-physical systems able to realize their optimal operation while they interact with the environment. So with this scale city that we have built, this is 20 by 20 feet or 6 by 6 meter long. We have about 75 robotic cars and about 15 drones. And we try to create a testbed that can allow us to do experiments within a transportation environment without having concerns about safety or having to spend a lot of resources. With this testbed, we can do experiments repeatedly, collect data, and draw concluding remarks based on what we have seen in a scale environment. We can purposely having backed actors in the testbed and then design controllers or algorithms that can help autonomous vehicles address this bad behavior. We do have the capability to drive these cars, and then we have a mixed traffic environment with human-driven cars and connected automated vehicles, CAVs. And then we try to develop the theory and algorithms that can make these vehicles coexist in a safe manner.
We usually consider the drone and the cars working together. So the main goal is to demonstrate that we can coordinate different kind of system together. Like if you have different vehicles, different kind of system, you have different kind of dynamics for them, and they need to exchange some sort of information. And it is not simple in real world.
Eventually, using this data, do the experiment, test our algorithm, and we want to use this in the real world to solve the traffic problems. It's still a gap between the current situation and the fully autonomous vehicle cars. So we also have to think about, in the middle time, how can you solve the human-driven vehicle cars with autonomous vehicle cars? Large language model now is really a hot topic because it has the ability to reasoning and give you the suggestions, decisions, and we are doing the control. Definitely, we don't want the large language model to take over the people with the decision, but we want the large language model can help us. For example, give us some suggestions to analyze the environment, provide more information, and also maybe dig in some hidden factors the human cannot find, but they can find.
Once you come up with a new method, a new algorithm, a new theory, you can prove the concept in simulation. But simulation is deemed to succeed. You need a hardware. We need to go beyond simulation. And this testbed can help into this direction to help us prove the concept, validate our theory, give us the opportunity to collect data, extrapolate information about this. So this testbed can be in between simulation and the physical world. Once we do experiments and once we mature the technologies here, then we can move on and do experiment in a real world setting. I think we're getting there. It might take a little bit of time. I am very optimistic, but at the same time, we need to make careful steps towards this goal. We don't have to rush this. Technologies have to become mature. We need not only technologies, but also new generation of engineers that can understand how we can get to this point. And this testbed can help train these engineers and create new knowledge that can get us there eventually.